These are the statements of Dalton's atomic theory, and what's really interesting to note about these statements is the time period at which they were developed, 1808. Because we read these and perhaps we think, well, yes, of course, elements are composed of atoms. But this was 200 years ago. Not all of Dalton's statements are still true today. Some have been modified and proven differently. For example, the second item here says that all atoms of a given element are identical, have the same size, mass, and chemical properties. Well, we now today know that not all atoms of a certain element aren't necessarily identical. There are things called isotopes, which we will learn about later, but different isotopes have different mass. Also, sizes of all elements aren't the same because some things can form ions, and that changes the size. The next statement in Dalton's theory is that atoms of one element are different from atoms of all other elements, which is true. Compounds are composed of atoms of more than one element, and the number of atoms in a compound is always the same. And finally, that chemical reactions involve the rearrangement of atoms. Atoms aren't created nor destroyed in a chemical reaction. Now, if I were to ask you to list what makes up an atom, most everyone has heard protons, neutrons, electrons. And what we'll do now is look a little bit about when they were discovered and the experiments that discovered those things. This is a diagram of a cathode ray tube, and this experiment was performed by J.J. Thomson. Thomson took a high voltage source and applied an electric current, had a cathode and an anode attached to this evacuated tube that had no air in it. And when he turned this voltage source on, there was a beam, and he couldn't see the beam with the naked eye. It's just drawn here for you. He detected the beam with a fluorescent screen. And what this beam, it turns out, was electrons. That's what the flow of electricity is, the flow of electrons. And what's interesting that Thomson noted is that when he introduced a positive charge next to the electrons, he saw that this beam, it bent and could be detected at a different space, so he knew the beam was bending. When he introduced the negative charge, he saw that it was repelled away from the negative charge, so that told Thomson that that was a negatively charged particle. And Thomson is credited with the discovery of electrons. Millikan's oil drop experiment, a little bit of history on radioactivity, etc., etc. So Thomson proposed this model of the atom. This is known as the Plum pudding model. Thomson had discovered electrons, and he knew there had to be a positive charge about an atom that would balance out the negative electrons. So this is what he envisioned, where the electrons were just embedded all in this positive sphere. Now, I don't know about you, but I'm not very familiar with plum pudding, so you could think of this like when you cut open a watermelon. The seeds are just the electrons all stuck into the red meat of the watermelon, which is just some kind of positive mass. And set out to prove that Thomson was right. And Rutherford did an experiment known as the gold foil experiment, where he took an alpha particle emitter. An alpha particle is a radioactive particle, and alpha particles are actually very weak. They can't penetrate paper. And Rutherford had a piece of gold foil that he pounded very thin. He used different kinds of metals, but gold is the one that is famous, makes the experiment famous. But in order for Thomson's model to be correct, what Rutherford thought would happen is that when he fired this alpha particle at the gold foil, that the particles would pass straight through because there was no extremely dense area to an atom. They didn't think they should be able to pass straight through. Alpha particles are weak. But what he found is not all of the particles passed straight through. Some were being deflected at various angles. Some were colliding with something in the foil and actually returning and being almost shot back to the source. And so what you have here on the right side is a diagram of how Rutherford explained this experiment. This is looking at a cross-section of the gold foil. And so most of the alpha particles pass straight through because they're passing through this region that's shown here in gold that we now know is an electron cloud, if you will. But every now and then, one of these alpha particles would come near some dense positive region. And because alpha particles also have a positive charge, as they passed by a positive area, they would somewhat be deflected. Sometimes an alpha particle would actually hit that positive region head on and would be deflected back to the source. And so we now know today that that area in the very center of an atom, that's the nucleus where the protons reside. And then in this area around the nucleus, that's where the electrons are.